In this little portion of the alcohols chapter, you will find nomenclature and properties and applications of alcohols. It's a very small portion, and in the next one, we will talk about synthesis and reactions. So during the nomenclature of alcohols, remember that alcohol will get priority over alkenes, alkynes, any kind of alkyl groups, and then halides also. So chlorine, bromine, all of that, they will come after the alcohol group. So the first thing that you do is you find the parent chain, which means the longest chain, and try to give the alcohol group the lowest possible number. And that's because it has the priority. And then you change the suffix from E to OL. So for example, methane becomes methanol. So you remove the E and then add the ol. So all the alcohols will end in ols, and that's how we know it's an alcohol. So for common names, the first two alcohols that we know are methanol, which is also called methyl alcohol, and then ethanol, which is ethyl alcohol. For the other ones, then you have to find whatever alkyl group you have and or the parent chain and then name accordingly. On this, the first few that we have here for you, in this one you will find the common names as well as the IUPAC names. Okay, so I will tell you both of those. The first one is 1-propanol, and now we have 3 carbons, so 1, 2, 3. And since the alcohol group is on the first carbon, you call it 1-propanol. Starting from 3 carbons, you have to start numbering the alcohol. With ethanol, you don't have to because ethane has only 2 carbons. So you can be on the first or second carbon, which is really not the second carbon then. It would be the first carbon. Okay, and so with the 3 carbon chain, then you have to say whether it's the alcohol group is on the first carbon or the second carbon. Okay, and so it would be either 1-propanol or 2-propanol. If it is 1-propanol, the general name is propyl alcohol because here is the propyl group. If it is 2-propanol, it's also called isopropyl alcohol, which of course you must have heard of. And the isopropyl alcohol comes from the fact that you have this isopropyl group here with the 3 carbons and the branching coming off from the middle carbon. So that's isopropyl alcohol or 2-propanol. And then here is 1-butanol, and 1-butanol is also called butyl alcohol because here is again the butyl chain. And with, of course, with 4 carbons, you also have 4 different isomers. Okay, and so butyl is one of the groups. The other group is sec-butyl. Then we have isobutyl, and then we have tertiary butyl. So these are all the other 3 alcohols that are possible. And on the top, you will see that they are the IUPAC names. So for example, sec-butyl is 2-butanol because here is the secondary carbon where the attachment was. And the isobutyl alcohol is 2-methyl-1-propanol. So here is your long chain, 1, 2, 3. And so on 1, you have the alcohol. On 2, you have the methyl group. Okay, and that's how this isobutyl alcohol becomes 2-methyl-1-propanol. And then the 2-methyl-2-propanol, that would be the tertiary butyl alcohol, which is also called T-butyl alcohol in short. Yeah, we have shorthand of shorthands. And then in case of cyclic compounds, you have to give priority to alcohol. So always number the alcohol first. And then as we did with cyclic compounds before, you will always number towards the substitution. Okay, so that way you get lower numbers, okay, for all the substituents. So once you start with alcohol, you will go towards the methyl group in the smaller number possible. Okay, and so this is 1, 3. Okay, substitution over here. You don't have to say that this is 1 cyclohexanol because it is understood that your alcohol is on carbon number 1. So writing 3-methyl-1-cyclohexanol would be kind of redundant, okay, a little bit. It's not entirely wrong, but you don't have to write it. Okay, so I would prefer if you don't do it, but I will not take off points if you actually do it. So in any case, and then of course the cis is coming from the fact that you have both of them going in the same direction. Okay, and so that's this. And then here is a bicyclic compound. And in case of the bicyclic, you have to remember that we number the longer chains first, okay, and not the smaller one. So the longer chain first. And so here you would number from 1, 2, 3, 3 alcohol, not from 6, 5, 4. So not 1, 2, 3, 4 alcohol. You still want to give alcohol the lower priority, although you do not start numbering from the alcohol because for bicyclic compounds, you have to start at the bridgehead carbons, okay, always. So that's the number for bicyclic compounds if you have alcohols in there. So, with the nomenclature, with the alcohols, there is one other thing that we have to talk about, and that is primary, secondary, and tertiary. And we've touched on it a little bit before, but we'll just go over it again. A primary alcohol is one that is connected to a carbon that is connected only to one other carbon. A secondary alcohol is connected to a carbon that is connected to two other carbons. And then a tertiary alcohol is one that is connected to a carbon which is connected to three other carbons. Okay, so it's like 1, 2, 3, and that's primary, secondary, and tertiary. So we have three different kinds of alcohols possible, and this is a very important part when it comes to alcohols. You saw that back in substitution reactions also, when we talked about primary halides and tertiary halides, that these things are actually quite important and they react very differently. It's the same thing for alcohols. We have different ways of synthesizing them, and we also have different ways of making reactions, okay, for them. So which is why it's really important that you recognize primary, secondary, and tertiary alcohols. Now, you can also have alcohol groups on benzene, and those kind of alcohol groups are then called phenols. Okay, those compounds, they're called phenol, and the phen is coming from phenol. If you remember, we call a benzene ring that's attached to anything a phenyl ring, and so this is the phenols coming from the phenyl ring, and then the ol is coming from the alcohol. Okay, and so usually we don't use benzene alcohol as a name. Okay, so it's generally called phenol. We will do more of the nomenclature of aromatic compounds when we get to the aromatics chapter, but at present we'll just know that phenols are aromatic alcohols. Okay, and so that's the extent. Okay, pretty much. So there's some examples here also. If you have compounds that have more than one alcohol groups in there, then they are named as diols, triols, tetraols, and generally after that you just call them polyols, okay, since you have many of the alcohols. All right, so that's how you would name them. If you have unsaturated alcohols, then you also have to include the alkene in there, although remember, your alcohol still takes priority as far as the numbering is concerned. Okay, so let's look at some more examples over here. So here is another molecule, a small one. It's not too complicated. So we have 1, 2, 3, 4, 5 carbons here. On the second carbon, you have the alcohol and the methyl. So this becomes 2-methyl, 2-pentanol. What you will also see here at the bottom is the new nomenclature, in which case you place the locant just before the functional group. Okay, so 2-methyl pentane 2-ol. And this nomenclature is really good when you start having really many different kinds of functional groups in one compound. If you have simple ones like in this case, it really does not matter a whole lot. It matters a lot more if you have many functional groups. So it doesn't matter to me which one you write. I just want you to be able to recognize both of them. Here is another one. Now this one is a diol. Okay, and so now this is 1, 2, 3, 4. So you have cis 1,4 cyclohexane diol, and cis because both of the alcohols are in the same direction, which is going up, or it could have been down. And then cyclohexane, of course, is the ring, and so on. Here is another one, but this is with a phenyl, okay, group. So now in this case, you don't have to start from the benzene. You take the longest chain, okay. For me, the way I look at nomenclature is that you try and keep it as simple as possible, okay. So there are certain rules that you have to follow, but sometimes it is possible to name compounds in more than one way. So I would suggest you find the easier way, okay, to do it as much as possible. And so here the longest chain is 1, 2, 3, 4. So instead of looking at the benzene ring and getting paranoid about how to name this little structure here, start looking at the chain. Okay, and so once you see this, you will know that on the second carbon, you have an alcohol. On the third one, you have a phenyl group. Okay, and so then the naming becomes very simple. It's 3-phenyl and 2-butanol. Okay. This one is called benzyl alcohol, and if you don't remember this one right now, I will not be too hurt because we will deal with this when we get to aromatic compounds. But this one is related to aromatic alcohols, so it's all right. But anyhow, benzyl alcohol, this is not phenyl alcohol. Phenyl alcohol again would be phenol. Okay, so there's nothing like phenyl alcohol. This is benzyl. Benzyl group is when you have a benzene ring along with a CH2 group on it. Then here is one with an alkene group on it, and this is allyl alcohol. Allyl coming from the fact that you have a 3-carbon fragment, 1, 2, 3. Okay, and remember in the allyl groups you have a double bond at the terminal carbon. Okay, and so the allyl group is actually joined at the carbon which does not have the double bond on it. And so this is allyl alcohol. If you had to name this in IUPAC nomenclature, you would number from here on the right side 1, 2, 3. So you have a 3 chain, which means you have a propene, and your alcohol is on the first one, okay, and right here, and the double bond is on 2, so this is 2 propene, 1 all. Here are some other diols, okay, and this one is 1, 2 ethane diol. Okay, so 1, 2 ethane diol, because you have 2 carbon structure, and on the first and the second one you have alcohol groups. This is also called ethylene glycol. Ethylene coming from the fact that this is CH2, CH2. If it was methylene, it would be CH2, just CH2. Okay, if you had propylene, it would be CH2, CH2, CH2. Okay, so the ene, actually the ethylene, comes for the fact that you have CH2 and a CH2. All right, so the CH2 group is the ene group, which is really weird because ene groups for us means alkenes. Okay, so this is something you have to learn to differentiate. Ethylene glycol is the general name, okay, for this compound. And then we have this compound where you have 3 alcohol groups. This is called 1, 2, 3 propane triol. Okay, the common name for this one is glycerol, and I think you must have heard of glycerol before. Once you get to more and more alcohol groups, then it's, you know, just have to have more numbering in there. With more alcohol groups, an example of compounds with 4 or 5 alcohol groups would be like sugars, carbohydrates, for example. Okay, but anyhow, this is kind of what the nomenclature of alcohols looks like. Now for the physical properties of alcohols. Alcohols are like water, okay, in a way. So if you look at the structure of water over here, um, the hybridization on oxygen over here is sp3. The shape of water is bent. Alcohols are pretty much the same way, okay, because here you have the oxygen with 2 lone pair of electrons and then 2 R groups or 2 bonds. And so the oxygen here is also sp3 hybridized, and the shape of alcohol around the oxygen is a bent shape. The other thing about the alcohols is that, of course, you have this OH, okay, and the OH provides for hydrogen bonding. And because of this hydrogen bonding, alcohols have very different properties than what we've been studying so far. Because until now, we had only hydrocarbons. We did not have any oxygen in any of the groups. But now we're talking about oxygen, and oxygen, not just oxygen. We have oxygen with hydrogen. So which means that now we're actually talking about hydrogen bonding. All right. And so because of hydrogen bonding, we can have different properties in alcohols. And hydrogen bonding is one of the stronger intermolecular forces, right? There are 3. The van der Waals, dipole-dipole, and then hydrogen bonding. And hydrogen bonding is one of the strongest intermolecular forces. They're almost as strong as a covalent bond. So if you have an alcohol, it will form hydrogen bonding with itself from another molecule, and in case of water, it can form, of course, hydrogen bonding with water as well. So that is something you have to remember. Okay, and so looking at that, you can talk about the high boiling points, and the high boiling point is because of the hydrogen bonding. It is hard to break this bond, and therefore most of the alcohols will have high boiling point, and they have high boiling points because we know that even methyl alcohol has a high boiling point. It's a liquid to begin with. Methane was a gas to begin with. However, methanol is already a liquid. Okay, it has a low boiling point, but compared to methane, it's high boiling point. And then, of course, since methanol is a liquid, then ethanol, propanol, these are all liquids. And then as you get to higher and higher alcohols, they will get higher and higher boiling points. Okay, and that's because of 2 forces then. You have the hydrogen bonding as well as you'll have the van der Waals forces then, okay, going on with the hydrophobic region or the non-polar part of it. So you'll have 2 different kinds of intermolecular forces as the chains get longer. So that is because of hydrogen bonding that all the alcohols will have high boiling points. Now, one of the things you have to remember about boiling points and all that is also the fact that you can have a single alcohol group versus a 2 alcohol group, like a diol. So if you're comparing between a monoalcohol and a diol, then obviously a diol is going to have a higher boiling point because it has two alcohol groups. Okay, and so that is something you should keep in mind when comparing alcohols and boiling points. Then let's talk about solubility. Alcohols are going to be miscible in water, and they are soluble because, again, of hydrogen bonding. Water has hydrogen bonding, and then alcohols have hydrogen bonding. So because of that, they're both soluble in each other and very nicely soluble in each other. In fact, ethyl alcohol is so soluble in water that it forms an azeotrope with water. And so you will never find alcohol, ethyl alcohol, as 100% alcohol. It's usually 95% alcohol because it forms an azeotrope with water. If you need to remove that 5% of water from there, you really have to use other techniques other than just dehydrating the water. So it's that soluble. But then the solubility will decrease as the size of the alkyl group increases. Why? Because now this is van der Waals forces, and van der Waals forces and hydrogen bondings don't go well together. So by the time you get to octanol or nonanol, nonol, nonanol, anyhow, it will you will start seeing two layers, okay, in there, because now the alcohol will not be soluble in water anymore. So that is how it is with the one alcohol group. Again, if you have two alcohol groups, then the solubility will change. So for example, if you think about sugar, which has 5 alcohol groups, sugar is so soluble in water. It's even more soluble in water than salt is because of the 5 alcohol groups which have very strong hydrogen bonding with water. So that's a little bit about the physical properties. One other thing I would like to mention is about the odor. Most of the alcohols are actually sweet, okay, in odor. It may not seem like it, but they are actually sweet. And I don't propose tasting any kind of alcohol, but alcohols are a little bit sweet and taste also. Okay, and case in point, glycerol, which is a very sweet alcohol. Ethylene glycol is also a very sweet alcohol. We'll talk about that later also. And then sugar, of course, we all know sugar is sweet. Okay, and see, it has 5 alcohol groups in there. So that's another physical properties of alcohols, is that they're sweet in smell and taste as well. Now don't go tasting alcohols. Here is a little bit of a comparison between ethanol and ether. We will talk about ethers a little bit later in the next chapter, but this is just a little comparison to show that hydrogen bonding is so important, okay, in the physical properties of substances, okay, because here we have ethanol and dimethyl ether. Both of these are what we call constitutional isomers, okay, they have the same molecular formula. However, ethanol has a boiling point of 78 degrees Celsius, whereas dimethyl ether is so low, okay, negative 24 degrees Celsius. And this is all because of hydrogen bonding, all right? And so because of hydrogen bonding, ethanol will be soluble in water and dimethyl ether will not. And as you're learning more and more about different functional groups, you will have to compare these physical properties across all the functional groups, okay? Not just between alcohols, but between alcohols and ethers as well. Now for another property of alcohols is that they are actually acidic. One thing you have to remember that alcohols are very similar to water. I kind of mentioned it before also with the physical properties, as in the high boiling points and all that, because of hydrogen bonding. And because of their structure is very similar to water, their properties are also very similar to water. So water can be an acid and a base. It's called an amphoteric substance, and the same thing goes for alcohols. Alcohols can be acidic or basic, okay, and so we'll start with the acidity first. And the pK range for alcohols is about 15.5 to 18, and the water is about 15.7, so you can see they're very, very close. And the acidity will decrease as the alkyl group increases, okay, which means that the smaller alcohols are going to be stronger acids, and then as you get to the longer chains, then the pK increases, and so therefore the acidity decreases. And that has a little to do with what we call inductive effect, if you remember from acidity and basicity, because remember, acidity is the ability of anything to donate protons, okay? And so how easy it is for any kind of a compound to give up a proton is really what's important. So how easy it is for this proton to go away. All right, and for methanol, it's very easy to go away, whereas for the longer chain compounds, it's not so easy to go away because these long chain compounds, they have an inductive effect of donating electrons, which means that the bond is actually quite good now. Okay, uh, this hydrogen, by the way, for alcohols, the hydrogen attached to the oxygen is the one that is acidic and not the hydrogens that is attached to the carbon because 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 oxygen is polar. Okay, so oxygen is very electronegative, and this bond between oxygen and hydrogen is polar, and therefore this hydrogen is the ionizable one, which is this is the acidic one, not the carbon hydrogen. This is not a polar bond. Okay, so this is the acidic proton. Something to remember. If there are halogens attached to the alcohol, they will increase the acidity, again because of electronegativity. So if you have a halogen over here, a chlorine or a fluorine, it would pull electrons towards itself and makes it easy for the hydrogen to go away. Okay, and so those are the things that actually make alcohols more acidic. Now, regarding the phenol, we'll talk about this again when we get to the aromatics chapter. Okay, and then you will know why phenol is so many more times acidic than cyclohexanol. Until then, just know about these small facts here. Okay, so this is for ethanol. This pK is for ethanol over here, and this pK here with 14.3 is for 2-chloroethanol. And 2-chloroethanol, you can see the pK has gone down, okay, from ethanol, and that's because of the chlorine. So anyhow, just look at this table. You don't have to memorize the number, just get a general idea of how it works. Now, regarding the reactions of alcohols as acids, you've done some of this before when we did the substitution reactions, because this is how you form alkoxides. Okay, and so you take any kind of an alcohol and treat that with sodium or sodium hydride. Okay, and then once you treat them with sodium or sodium hydride, you end up getting the alkoxide ion. So in case of methanol, you'll form methoxide, and then the sodium ion is still there as the counter ion. So this is sodium methoxide. The sodium is still there. The H goes away as hydrogen. Okay, it's not shown in the reaction, but that's where the hydrogen goes away. But you can take any kind of an alcohol and treat that with sodium hydroxide as well, and then still get an alkoxide. The only problem is that the product that you form is water, and water will react right back, and so you will have an equilibrium instead of a forward reaction. Treating an alcohol with sodium gives you a forward reaction, whereas treating an alcohol with sodium hydroxide may not give you a full forward reaction. Okay, will be more like an equilibrium and actually may lie more towards the left side than the right side. So here are some other reactions, and then of course this is the one that we did back in the substitution chapter, okay, where you had an alkoxide, you treat that with a substrate and you end up getting an ether. Okay, so this is where we learned it. So in any case, that is a typical reaction for alcohols, and you have to kind of remember this property, because this property of alcohols will come up over and over and over again, the fact that this hydrogen is the acidic hydrogen. Okay, so you have to remember this part, that alcohols are acidic in nature. And then here is the one for basicity. Now, the basicity of alcohols does not come from hydrogen, obviously. The basicity of alcohols come from the oxygen. Okay, and so oxygen has the lone pair of electrons, and these are like Lewis bases then. Okay, which means that you have the electron pair donation going on. And so you can treat any kind of an alcohol with an acid also, and you will protonate the alcohol. And we have done this also in substitution chapters, where you would protonate an alcohol to make it a good leaving group. Okay, and so the alcohol oxygen will give electrons to the hydrogen, pick up this proton over here, and then the halide, if it's HCl, hydrochloric acid, then you'll have the chloride ion here also. Okay, and then you form the oxonium ion, which is over here. Now this is H2O that is you've just formed, and so this alkyl group over here, depending on what kind of an alkyl group it is, you can form a carbocation or not, and that is dependent on the reactions. Okay, but this is a very typical thing. And what this also tells you is that alcohols are really sensitive to acids and bases. So when you work with alcohols, you have to be careful, okay, how you use them and how you store them, because they are so reactive. Alcohols are really prevalent in our society. And when we say alcohol, people think of only one kind of alcohol, and that is the entertainment kind, which is the drinking alcohol, ethanol. But really, there are many other alcohols in our lives. So, in the next couple slides, I will just kind of talk about where you will find alcohols and what do we do with them. Okay, so for example, methanol, which is also called wood alcohol because it is actually obtained from wood. And now remember, almost all the alcohols are obtained from some form of carbohydrate. Okay, and so that is fermented. Once it's fermented, that's when you get alcohol. Alcohols are small molecules, methanol, ethanol, for example. These are small molecules and they're usually obtained from large carbohydrate chains, okay, like starches, celluloses, all those kind of things. Those are really long chains. So once they ferment, you get the smaller pieces. So methanol is also called wood alcohol. It's a very, very common industrial solvent. It's also very common in the labs. So you'll find methanol a lot. So it's also called methyl alcohol as usual, of course. Methyl alcohol is also used in spirit lamps, as we call them, in cases where you don't have Bunsen burners, which really is never going to happen. But in any case, it's also called spirit. Okay, in some ways, ethanol is also called spirit, but when people say that we're using a spirit lamp, they really mean methanol lamps in that case. Methanol is also a very common fuel for Indianapolis races, okay, and that's the car races. And why is it a good fuel? And that is because it burns very nicely, okay, and so it burns very well and it gives good mileage, obviously. Um, the problem with methanol is only the fact that it's toxic, all right, as far as when you drink it. If you don't drink it, it's all fine, okay? But if you drink it, then you actually get blind because of methanol. But other than that, it's a very good alcohol as far as you can see a source of energy or as a solvent. Ethanol is the more common solvent that we hear about, and that's what I said is the common alcohol. When we say alcohol, we really mean ethanol for most part, or ethyl alcohol. And again, ethanol is obtained from fermentation of sugars and starches, whatever that might be. And different kinds of sugars and grains will give you different kinds of alcohols, and that's why, not that I'm saying you should go to a liquor store, but if you look at the liquor site, then you will see so many different kinds of alcohols, tequila, gin, whiskey, whatever it is. They're all different kinds of fermentation processes and different types of sources for fermentation to produce alcohol. Once those alcohols are produced, of course, you have to distill them. Once you distill them, you can also get hard liquors. You distill them over and over again, and the more you distill them, the harder it gets. Harder means that it is more pure alcohol. Okay, that's what it really means. You have to remember that when fermentation happens, you also produce water, and water will be there. Okay, and as I said before, when we were talking about solubility, is that water and ethanol are really good buddies and they will never separate out. Okay, and so you end up getting an azeotrope, which is 95% ethanol, and it's really hard to get rid of that 5% water, okay, that is an ethanol. So no matter how much distillation you do, you will always end up having 95% ethanol. Now, when we buy liquor as an alcohol, we usually get them as proof. And so when we say that something is 10 proof, it really means that you have 5% alcohol in it, okay? So which means that you will never, ever, ever get something that is 200 proof, because 200 proof means that you have 100% alcohol. 100% alcohol, not possible, except in a lab, okay? So you will never ever find 200 proof alcohol. And by the way, if you're buying that amount of alcohol, you have serious issues, okay? Because that's a lot of alcohol in any kind of a drink. Anyhow, so then we have azeotropes, which is of course the 95% ethanol. That's what usually alcohols will be, okay, for most part. However, we do get alcohol as in pure ethanol solvent in labs, and they have to be made by special dehydrating techniques in the industry to remove that 5%, okay. It's usually called denatured alcohol because typically there is a chemical added to this alcohol so that you cannot drink it anymore, okay. So that chemical does not interfere in its properties as a solvent or as a reactant. However, it does make it undrinkable, okay. So don't think that just because it's in a lab and it's 100% alcohol that it's consumable. It is not, okay. It's toxic. So ethanol has two purposes, okay? One purpose that I've just mentioned to you all over here in the first 4 points or 3 points is that it is, of course, the drinkable kind of the alcohol, unlike methanol, which if you drink, you go blind. But ethanol, you can drink it. It's not that you don't die from ethanol, you do, and that's called binge drinking. So with drinking alcohol, there are many issues, and I'll talk more about it in class also. But with drinking, there are many issues, okay? And so there is alcoholism, and then there's binge drinking, okay? Which means there are two different kinds of problems that come with alcohol. And then, of course, then there's the digestion of alcohol. How does it happen? Digestion of alcohol happens in the liver, okay? And so that's why the liver is the first organ to go if you're an alcoholic. So in any case, we'll talk more about this in class. However, ethyl alcohol is the only drinkable kind of alcohol possible. It does not mean that it is a good alcohol. It just means that it has low toxicity compared to the other alcohols. Then the other aspect of alcohol that's very common these days is, of course, the alcohol as an energy source. Just like methanol is used as an energy source, ethanol is also a very common energy source. About 60% of corn in the United States is stored just to produce ethanol. Okay, and so it's a really big business. Okay, especially if you go to the Midwest, Iowa, Kansas, all those places, they have huge amounts of corn storage, and they're storing this corn for producing alcohol. And this alcohol will be mixed in gasoline, and that's called gasohol. And why do we add ethanol to gasoline? And that is because it burns the gasoline a little bit better, and this is called oxygenated gas. And when you have oxygenated gas, it burns a lot better than the non-oxygenated kind. Okay, and so you need to have some sort of oxygenated fuel in order for it to burn properly. And burn properly means efficiently, and of course with low harmful gases. Okay, the gases that come out of your car after you burn the alcohol, or excuse me, after you burn the gases, is actually like sulfur trioxide, nitrogen dioxides. So the ethanol or any kind of an oxygenated agent in there will make sure that all the oxides that come out are actually the peroxides, which means the highest oxidized state. Okay, so which means not sulfur dioxide, but trioxide. Okay, that way the sulfur trioxide is already oxidized and will not do any further reactions when it comes out to the atmosphere. So it really has quite a lot of implications as far as the environmental chemistry is concerned, okay, and as far as our environment is concerned. So anyhow, those two alcohols are very common in our lives. Then there are a few more. One is isopropyl alcohol, which you will find in any kind of a pharmacy, and that is a disinfectant. Most of the isopropyl alcohol that you find, I think, is about 12% isopropyl alcohol. Again, this is not a drinkable kind of alcohol. This is still just used for topical purposes, and so you can disinfect if you get any wound or something, and then you can just use it on your skin. Definitely not for drinking. And then there's the ethylene glycol. Remember, this is the glycol as in the two alcohols, ethylene, two carbons, and then glycol meaning alcohol on two of those carbons. And this is a very common antifreeze, and this is something you might remember from your Gen Chem 2 is when we talk about Raoult's law in case of properties of solutions, is that when you add a solute to a solvent, then you can elevate the boiling point and you can depress the freezing point of water now, or any solvent for that matter. And salt is not a very good agent to use for depressing the freezing point of water. It's very good when you have snow on the road, and that's fine. So you can salt the roads and depress the freezing point. So it's all melted, when you come out. However, in your car as a coolant, you cannot use salt because it causes a lot of corrosion. So in those cases, ethylene glycol becomes a really good agent to add in there. It doesn't cause any corrosion, and it's very soluble in water. So then you do the calculations and you figure out how much of elevation or depression you want in the boiling points and freezing points, and that becomes your antifreeze then. Antifreeze has a little bit of a problem, and the fact is that ethylene glycol is a little sweet. And the problem with the sweetness is not for us so much, but it is a problem for pets, okay? And that's where they sometimes get poisoned because of ethylene glycol, because in case your antifreeze is leaking from the car, then they end up licking it, and because it's sweet, they like it, and so there is, they end up getting antifreeze or ethylene glycol poisoning. Okay, and so in that case, you should definitely take your pet to the vet. Then there's glycerol. Glycerol is a 3-carbon structure with alcohol group on each of those carbons, and this is used as a medication. Very common. Glycerine, you might have heard of glycerine also. Okay, same kind of a thing. Glycerine is a little bit more glyceraldehyde as well, but glycerol is where you have the alcohol groups, again used as medication. Glycerol is also very sweet. Okay, now we're getting into more alcohol groups, and so it gets sweeter and sweeter until you get to sugar, and which is all carbohydrates. Okay, and they all have alcohol groups. Not all carbohydrates are sweet, by the way. Fructose and glucose, the combination of those two, which is a disaccharide then, and that's called sucrose, and that is what we eat as common sugar, very nice and sweet. Okay, fructose by itself will give you a different taste. Glucose by itself is going to give you a different taste, but you combine those two together, you put them together as in a chain, and those two molecules combined gives you sugar, which has a different taste then. So almost all carbohydrates have alcohol groups in them, but then again, not all of them are sweet. They have sweetness to varying degrees. Okay, but anyhow, those are some of the alcohols that we find in our lives. So what I want you to know from this portion is the nomenclature of alcohols, of course, the classification of primary, secondary, tertiary alcohols, the physical properties, solubility, and boiling points, acidity and basicity of alcohols, and the basicity comes here right here in the alkoxide formation. So you should know all to write all these reactions out too.